No, just kidding. Let's get started. Okay, sweet. So hey, everyone. Thank you for joining me in the final workshop, it sounds like, of the entire hackathon. Today, we are going to cover something which underlies most of the products we use. I want to tell a little bit of a personal story about it first before we get started. Databases, underlying data, to me, were one of the most frustrating things when I was a computer science major in school. So I had programmed before. I built lots of kind of hacky little apps, but I never felt like anything was real, right? And even when I studied and played with databases in school, a lot of times the data sets were already prepared for me, were already cleaned for me. And so I may have learned a little bit of SQL. I may have learned how to manipulate the data inside of a database, but I never felt like I could take what I was learning in class and apply it to a real project, like from scratch. So the way I built this workshop is certainly about databases and SQL and how you can manipulate data in a way that lets you ask your application questions and learn things that maybe you didn't even think about when you created it. It's a super useful skill. But in addition to that, I've created the entire set of scripts that lets us take a real-world data set, one that I think probably most of us on this call can relate to, which is like a course schedule for the university, and shows step-by-step how to get that data off the web, get it into a format that we can look at it, turn that into a format we can load into a database, and then get that data set loaded into SQL. So in the field of data engineering, this would be called ETL, which is what this folder is that you see on my desktop, the ETL folder. It's totally a bunch of hacky bash scripts, which is the way often it happens in the real world. So I wanted to make this whole workshop realistic from that end. How can we start from data that exists out in the world, not just create this perfect little SQL database to start from, but how can we start with a data set that we want to build an application on top of and then work it into our app. So this is, if you think about how this could apply to the challenge for this particular hackathon, right? If we're thinking about music and media, one of the first things you can think about is something like getting your Spotify data out, right? Getting your history of track listens, your albums, your playlists, and munging them this same way into the database itself. So that's the framing that I want to give you, right? This is not just about the database once we have the data in. It's about how to take that crucial first step of moving from a real world data set into data that you have in a database. Now, full disclaimer here, I gave this talk earlier today at HackKU, at another hackathon that's going on at the same time. I use their course data not only because I'm a KU grad, but also because they have like one of the easiest formats to scrape from. So before we move on, before I show you the actual data set and how we're going to load it into the database, I'll pause for like, I don't know, 10 seconds. If anyone has questions, feel free to ask them real quick in the hop-in chat. That's where I'll be keeping an eye out during this workshop so that I can make sure I catch any questions you have. So any questions? Awesome. 10 seconds. That wasn't quite 10 seconds, but 10 seconds really is a long time when you wait for it. Manager pro tip, if any of you end up being managers anytime soon, when you ask a question in your one-on-ones or your team meetings, always give that 10 seconds because it gives people time to really, really think if they have a question. Okay, so as I said, we're going to take a real-world data set, a course data set for fall 2021 at KU. We're going to pull down every single section of every single course that will happen at this, I don't know, approximately 30,000 student university next semester. We're going to transform that data into a form that we can load it in the database, and then we're going to explore it a little bit once it's in the database. So one of the things to know here is that data can take many forms on the web, out in the real world, and very few of them are suitable to directly use in a database. So to give an example, the schedule of classes for KU, right? It's a web form with this is, by the way, the advanced options as well, with a bunch of options. But our leverage here, the thing that we recognize and can take advantage of, is that when we click on any of these, preferably one that has like a lot of classes, so we won't even filter it down by course type, and we search, we've chosen Excel file here, right? So we found the secret backdoor. You can use this to get web page results, but you can also pull an Excel file of all meeting times. So fall 2021, undergraduate, let's even make it undergraduate and graduate courses. We really want everything we can get here. Online video, we want everything. When we click search, note what happens. What? So this query, just to let you know, it hits the entire database and pulls every single course section for the whole semester. It takes about 45 seconds, so I'll cut it there. But notice what we pulled out. So if I hop over into, say, VS Code here, let's open a Scratch buffer, actually. So code, Scratch, txt, and I've got my terminal jacked up all the way up here. So we'll split it. That new tab that got opened has a bunch of stuff. It's a web address, just like the web page was before. There is this interesting action endpoint that we're hitting, which is our first clue that we've found our way into the data. But then all of those options that I saw in that web form are appended as search params, right? As query params. Here's the key. Here's the value, which is blank in this case. Here's another key, here's a value, here's a key, here's a value. So that whole form turns into a URL that we can hit certainly in the web browser to download this file, but we can also take advantage of it and we can, I don't know, wget it. So this is a command at the command line that will let us download a file. And so if we wget that, and then we give it well, we won't even give it a default output. This is just like loading it in the browser. And if we do that, and, oh, well, we have to quote it, interestingly. So let's see. Single quotes, will that work? Okay, it won't. Luckily, I coded this up earlier. Sweet. So in this directory, which, switching back over to GitHub, you can see there are 3 phases. What we're doing right now is the extract phase. These are kind of standard ways to think about data engineering. Oh, it's double quotes, that's why. So wget, we're gonna get this entire URL here, this big long thing, and then we're gonna output it to a file inside of this directory. So if I copy my actually composed command here, I missed a quote at the end, which I will make sure I get over here. There we go. So I'm still getting, that's so interesting. Oh, well, it's because I used get. Awesome. So this is going to take about 45 seconds. It's going to load a file for us. We will see in just a second what that file looks like. Any questions meanwhile? You can only see the GitHub screen. Is that still the case? I wonder if it's lagging. Oh, changed on your end. Okay, good. Sweet. Yeah, it sounds like we might need to reload to make sure that the like the buffering of the video catches up. So if it feels like you're frozen and I'm on a different screen talking about something you can't see, maybe just give the entire web page a reload. Control or Command R, and then if that doesn't work, maybe a Control Shift or Command Shift R to do a force reload. Sweet. So you can see in my VS Code, what we've done at this point is downloaded a file. The way I set the script up, just a little bit of structure on top of my hacks. It uses the current date stamp. So this is what's called a Unix epoch. It's how many seconds have elapsed since January 1, 1970, to be precise about it. But the idea here is when we pull this data set, it might change. It might change tomorrow. It might change in 1 hour. So one of the principles of doing this kind of data extraction is that we want to make it repeatable, and we want to have data provenance. So I'll take those two terms in order. Repeatable means I can do the same thing over and over again. That's why I wrote scripts in the first place. Even though this is just like a hacked together data pipeline for a workshop at a hackathon, it's even got the word in it. I want to make sure that I can run this several times and know each time where my data set is coming from. So this first phase gets the data off the web, and this is the point at which I record the exact timestamp when I got that data. Then, if I discover later on that there are changes or discrepancies between my data sets, this number, as you'll see, follows all the way through the process. Okay, so that's step one. Now, if we look at what's in this extracted file, and by the way, all of this is in the GitHub repo. You can run this stuff yourself with one big caveat. I wrote it, on a Mac for Bash as a shell, and there could be cross operating system differences and cross shell differences as well. I didn't really test it on other OSs, but if you find bugs and you fix them, feel free to send a PR to this course material. So if I look inside of that directory, I'll see I already took a data set earlier, and here's a new data set as well. So these are the versioned Excel file extractions of the whole course. If we look at those, let's see, ls or extracted, we'll see there are about 2 megabytes, and we'll see how many rows that is in a second. So step one, extraction. We have to get the data from somewhere into a computable form. It can't just sit on a web page. If it does, we've got a lot more scripting to do. So our first hack is find the data in a format that's reasonably easy to modify. But it's not exactly easy to modify. This is an Excel sheet, and if you've ever looked at what an Excel sheet looks like character by character, it's not pretty. So what's a good way to do this? Let's do a WC, let's do a head C. So this is the head command, which gives you a certain number of lines from a file, which is passing -C, which lets us instead get characters, or technically bytes. So we're going to get the first 100 bytes of one of these files extracted. Let's get 16. Let's get the newer one, which is 808. It looks like. Cool. So it's a mess, right? It's a binary data format that has all kinds of compression and custom headers in it. So the next thing we do once we extract the data is we transform it into a form where we can use it. Now, I can, instead of popping over to GitHub, this time I'm just going to open the script to do the transformation inside of my VS Code instance here. So if I look at transform, it's a slightly more complex script. It's a bunch of hacky bash. This is what I want. One of the most important things I can teach you about this, having done everything from like starting a startup or a business or a project as fast as possible, to some of the work I did when I was at Google on like massively parallel data processing systems, like building the systems that run jobs like this, is that at the individual lines of code level, you should start with the tools you know best, and it's okay to hack. It really is. I have these date stamps, right? That's a nice, clean like flow of the data. I know the transformations I want to make. I comment them at a high level. So, make sure we get the latest file, remove some noise that I happen to know is inside of Excel files because of their format. Here's me documenting something that's special about this particular Excel sheet, and then take the column names that come from the data, which if we were to open this in Excel, you'll see they have spaces and punctuation and all kinds of stuff, and turn them into SQL or Postgres friendly ones. All these steps, even if this became, did any of you attend the GitOps workshop earlier today, right? Like that's the other side of the spectrum. You've got a huge company that has known data processes. It needs to run repeatably all the time. And that stuff is like crucial to a business like Centene. So that's the point at which you start spinning everything up in Kubernetes with Helm charts, like you may have seen at that workshop. Everything's in Docker containers, so everyone can use the same tools with the same environment. But never forget that process that's central to the business at some point started with one person saying, oh, there's a data set somewhere in this business or somewhere out in the real world, and I need to get a hold of it to do something with that data. And usually, what does it start as? A couple hacked together scripts. So be careful about the structure. Introduce like an extract, transform, and a load step. But then when it comes to the code, the way that you implement it, do it however you can quickly to get at the data itself. Any questions about like this notion of how to start, how to hack together the first version of a data pipeline? I'll do a full 10 seconds again. By the way, if you hear any yelling or stomping, that's my 4 kids and wife. I'm in the basement right now underneath the kitchen, so we may hear some noise as we go. I think I hear the door opening, actually. Okay, in the middle of a workshop. Love you. Okay, sweet. All right, we're over our 10 seconds now, and you've seen my domestic tranquility far too much. So this transform script, it takes that Excel file, it uses a fun little hack up here, which you all feel free to use, which is it takes the sheets.js Excel command line, and in one line translates an Excel file to a CSV file. And all of this is just super hacky bash var setting to make sure that we take that date stamp and we pass it through. Conditionally, if we don't have a data set yet, we use the sample data set. That's what this stuff is. So let's run our transform now. All right, so as I said, it defaults to the most recent data set. So if I just run /transform, in all of these shell scripts, I set an option called X, which shows me all of the commands as they go by. This is like my poor person's logging, right? Like it logs each command as well as the output of it. So if something happens to be broken in my quickly hacked together script, I can see it more easily without having to print every command or something like that. So at this point, like we had in our extracted folder, the original data set, the base data set. If we look now in our transformed folder, see there's the same thing, but it's a CSV file now. So let's see the difference. First, let's open an extracted data set. It was 161,808. Microsoft Excel will take like 5 minutes to load or whatever. So slow. There we go. That wasn't too bad, actually. We see the original data set here. These are the headers I was telling you about, like spaces in the middle of them, capitalization, random punctuation. These will not be good SQL column headers. So if I now open recent, oh, interesting. No, that's not what I want, though. Cool. Extracted. If I now open a transformed version of that same data set, you'll see a few things change. One is that we now have standard, like snake case, same as Python headers that we transform those into. Really, though, that's it. We turned Excel's file format, however, into something much more computable and compatible with a database. So if I look at this on the command line again, and this time I do a head with -n instead of -c, we're looking at numbers of lines now. And I look at my transformed data set, then we will see 8. Maybe the actual count of lines. So let's do 6 lines, which is the default, by the way. Okay, so now we've got CSV. This is something that most programs can deal with. And when I say most programs, I include Postgres. So the last phase of just about every data pipeline you've ever worked with is the load phase. We've extracted our data, we got it off the web, we figured a hack out. We've transformed it, we cleaned it up a little bit so that we can use it in more programs, including our database. And our last phase is to load the data set. So just hopping back to GitHub quickly for reference. Unfortunately, alphabetically, they're out of order, but extract, transform, and then load. Load is the same. It's a hacky bash script. We check that we have 2 commands. One is psql, which is the command line that lets us use a Postgres SQL database from the command line. And 2 is the tool that my company builds. It's called Platter. And the whole point of Platter is to make it a lot easier to start and to integrate Postgres databases anywhere, including, by the way, in like serverless backends and stuff like that. There's this whole client stack which lets you use Postgres statelessly in serverless context instead of just with connection pooling and stuff like that. So this file is just gonna do a little bit of transformation of file names, and it is gonna strip that header row off of the CSV and create a table based on it. This is probably the biggest hack in the whole ETL code base. I could walk through this if anyone's interested later, but I want to make sure we get onto the database and playing with the data itself. So this 5-liner here reads the columns in from the CSV file, transforms each into the inside of a query to create a new table based on that same timestamp yet again, that will let us load the rest of the CSV file's data into a Postgres database in this case. So we create the table, and then we load the table. There's a handy little pSQL command called \copy, which will let you load a local CSV file, in this case, with a header, with commas as its delimiter, into a Postgres database, which could be local. But in this case, because it's hosted with Platter, it's actually like a multi-tenant serverless Postgres database inside of Google Cloud is our backing store for this cluster. So we create that query, we run it through pSQL, getting the address to our database from Platter, which is this little subshell here, and voila, we're gonna load our data set into a SQL Postgres database. So yet again, I just made that a simple executable. We do load. This one takes the name of a Platter database or of a Postgres database in general. So let's create one. I want to show you really quickly how this tool works. So I've already got from platter.dev. We go there, we go to register. I think I'm logged in, so it'll bring me straight to my dashboard. Secret keys, but you can't see them. The idea, though, is you can go to dashboard.platter.dev/register, linked also from platter.dev, and create an account really quickly. Once you do that, you can log in the command line interface, the CLI, and it lets you do things like this. Instead of going into AWS or GCP to create a database, we just go with Platter, Postgres, create, and we'll call this one PickHacks demo, no, PickHacks workshop. That looks good. Let's do it. Skip this stuff. This is for when you use this in like a serverless code base. You can actually use the database, interestingly, directly in a website as well, but we'll skip that. If you have questions about that, hit me up in Discord later on. We also don't even need the client. We're just going to create a database. So Platter Postgres. Now we have a branch URL. Platter is a branching database. So if I show you Platter Postgres branch list instance, PH workshop, this we'll see there's branches to your database. So there's a master branch that we start with, and I can branch the entire database instantly by saying Platter Postgres branch create. We'll say, I don't know, something like feature branch. So this gives us the ability, just like we try a new experiment on a branch of our Git repo, to do the same thing with all of the state that underlies our web app. It's a pretty powerful paradigm that we're building at Platter, but it works like this. You get the instance, you get its branches, you create a new branch, and boom. Now your database live every time to make sure we're consistent has 2 branches. Each of these is a fully independent Postgres database with its own connection string. So all of that is to just bring us back to the fact that we want to load into this database now that we've created it, our data set. So /load, and our name is PH workshop. By the way, apologies that the branch name is still master and not main. I know the default these days in GitHub is main. We actually needed our branch to be longer than, I think, longer than 4 characters up until a few days ago. we've just fixed that so that the branches can be shorter, and now we're going to move master to main so it will fit your default GitHub workflow very soon. PH workshop. And our ETL script will do its magic. We'll see at the end. A crucial line, we actually delete to make sure that we don't double load any data with a particular timestamp. And this is the important line, 17,841. That is how many sections of courses that KU has for fall 21 inside of its course database. I will stop now because we have done something fun, I think at least. We've taken real world data. We've done the thing that nobody ever taught me to do in school, which is like, how do you take real data and build something based on that, not just these weird classroom exercises. It is now loaded fully into our database. And our next phase is going to be to explore that data and to play with the structure. And if we have time at the end, to turn what's called an unnormalized data set, one that doesn't have different tables for different kinds of entities in our course data set, into a normalized one that we could use, underneath a web app that lets you build your own course schedule, for instance. So I'll take 10 seconds for questions here. That is so weird, Jonathan. I'm so sorry that the reload on the tab is necessary every time I switch my screen. What I can do to hopefully help with that is, as we're in the SQL database side of this, we're basically going to stay in the console the whole time. So that should make it easier for you. I'll also try to thrash between windows generally less as we go. I know I kind of move around fast sometimes as I'm doing this stuff. So, any questions about what ETL, extract, transform, load means, the way to make a quick and dirty, yet also extensible and maintainable data loading process, and kind of this notion that even at the beginning, you want it to be repeatable and you want to keep data provenance, where and when the data came from. Any questions? All right, no questions. We can hop straight in then. Sweet. Okay, so just to review, some of you may have joined a little bit late. What we've done so far is we've taken a real-world data set, the KU classes schedule, and the reason it's KU and not PickHacks. First of all, I did look at it's MST these days, right? I forget. It used to be Rolla, I think. The name of the university is Missouri Science and Technology. Is that right? Did I get it right? Yes. Okay. Good. Phew. MSNT, thank you. I actually looked at your course data to see if I could hack it this afternoon. It's way messier to pull your course data. You should complain to the administration about the way they expose this stuff. It's like a bunch of ASPX pages, and you have to request way drilled down in the data set. We could build an ETL for that. It would not be a few hours. I think it'd be a few days to get it right. So Nate works in IT and is not surprised. Well, that's many IT organizations for you. You get a bunch of people leave, new people come in, and before you know it, nobody knows why the process really works the way it does. So we got this course data set from KU. We pulled it into an Excel file. We transformed that Excel file into CSV and cleaned the data en route so that it's suitable for a SQL database. And then we loaded that data into a database. This template, all of these hacky bash scripts that I wrote here, is a wonderful template cleaned of all that cruft for just about any extraction, transformation, and loading process that you need for data. Just fill in the blanks, basically, right? Delete all of the stuff that comes after. Well, maybe you should keep this because it's a good way to make sure your bash scripts stay in good shape. It will fail if any command fails and stuff like that. But extracting the data set, transforming the data set, and loading the data set, this will be a common shape for almost every data extraction project like this. Cool. So let's see the stuff in the database itself. At this point, for those of you who came in late, also, let me share this link again one more time. Right there. You can follow along in this. There's a pretty extensive README on one. Unit 1, I can add more to this later, but this will show you a lot of what we're going to do interactively, show you documentation and exploration inside of pSQL itself, and should be a good start for you to learn how to do this with your own data sets. But as for me, I'm going to be doing it all live, because why not live code it and see what I can mess up and relearn as we go. Okay, so we loaded our data. We know it's in the database, but we need to connect to that database, which is somewhere in US Central 1, I think, in Google Cloud, hidden away. This is another thing that we like to do at Platter, is make the data a lot easier to access while still staying secure. So the way we do that is, if I run pSQL on my computer right now, because I have Postgres installed, it will, like you would expect, connect to my local Postgres server, which is running my own database here. It looks like I loaded it at one point to test it locally as a fallback, just in case the network wasn't working. But instead, if I want to connect to my Platter Postgres instance, I just run, this is called a subshell. This is going to run another bash command as a child process of the command I run. It's going to get its output, and it's going to basically put it in the same place where this dollar and then parentheses are. So I'm going to run here, Platter Postgres branch. So for a particular branch, I want the URL. The branch I want the URL for is called master. The instance, as we saw above, was called PH workshop, I think. Let's find out. So this is going to run pSQL, but give it a connection string, which will allow us to connect remotely to that database. Cool. All right, so that database has a gobbledygook name. We randomly generate it. You can see that it's also got a different server version. Our shared cluster right now runs 12.5, the previous major version of Postgres, but the client is usually backwards compatible with any number of server versions. As you can see, this is something we often screw up when we build databases in the cloud. It's by default, it will only accept SSL, secure connections. If you've ever spun up a database in Google Cloud or AWS, immediately try to connect to it because you realize the security's off, you're passing your plain text query data, even your password across the network. We don't allow for any of that. We do all the configuration up front. But what we'll see inside of this database, you can find out with a wonderful command called \d. So what this does is it shows you all of the relations, aka the tables that you have in your database. We just loaded one. As you can see, that same timestamp that we created with our original extraction passed through all those processes into the database. This is what I mean by provenance. Now we can track for each data set. If we see changes or if we made an error in the way we loaded it, we can purge the data all the way downline into the database. This is what makes it repeatable, and this is what makes us understand the provenance of the data that we're working with. Yes, \d is wonderful. \d also does many other things. Let me show you a few. First of all, if you ever want to see all of the other tables that are in your database by default, add a capital S at the end. This is for system. All of a sudden, we've got a lot more. So this is all the built-in stuff. Note the schema over here. The schema it's something inside of a database, but a schema can contain 0 to n tables as well. Postgres, because it's old school, calls these relations, but when we say relation, what we mean is table. It's the relationship between the different columns and the data that's in them for each row. So these columns are related to each other, hence a table is a relation. If you want to see, I'm pointing now at my whiteboard on the other window if you need to switch contexts. But here I drew first the logical hierarchy of things going on in a Postgres database, and then I drew the systems view of that. Okay, so a Postgres quote-unquote server is really a Postgres cluster. That's what it's called technically inside the system. But it is a set of processes that runs on a machine that manages the storage and the query and connection interface for multiple databases. What you create when you use Platter to create a database is this. It's the second level. It's a database. That database can contain many tables or relations, and those tables or relations within the database are grouped into schemas. If you want to be really anal retentive about your Greek, the plural there is schemata, but trust me, it's better to just say schemas generally. We're a long way from ancient Greece. So the schema that I enabled, sorry, clicking on my PickHacks hop-in window instead of my SQL window over here. I added capital S for system, and that opens up all of the schemas to this \d query, including PG catalog, which has a bunch of stuff, built-in functionality, tables, views, tables and views over here that show you like all of the things you might need to know about your database, its configuration, the functions you can run, like the different metadata about the tables you have. There's a lot of this. In fact, I think there's on the order of 90. Oh, it's even more in later versions of Postgres. So 126 of those system tables. And then note this last public schema, which is the default schema to work in a database, as our one table. That's a table, and the user is this user. The reason that Cloud SQL Admin is the owner of all the other tables is because this is a Google Cloud Platform database, and this is their version of like the super user. It's not quite a super user since this is Google hosted databases. A lot of times when you're running your own locally, you'll see that these have the default super user Postgres. Cool. So that is all of the things that are available in this entire database, all listed out for you, all with 3 characters. Pretty handy. If you want more information, sometimes, depending on the command, you can add a plus on the end of it too, and note that now I have the same stuff I had about my table, but now I also see what kind of persistence it has, the exact size of it, and the metadata description field. So you can combine these to get data about all the tables, including the system ones, and extend it to tell me about persistence, size, and description. And there we'll see a lot more information. Cool. So this lets us explore this level of the hierarchy, like the database into the schemas, into the tables. But what about the table itself? What about the data we care about? It's pretty handy. We can do \d again and just give it a table name. It auto-completes for us. And if we look at this now, we see the columns for this table itself. This is the data that came out of the website through the Excel file into the CSV file and into Postgres so that we can manipulate it. But does anybody see anything weird about this data set right now? Anything notable? I wish we were like on a video screen share. It'd be easier to do raised hands, but let me know in the chat if you see anything. So I'll note one thing. It's expected based on the way we loaded the data, but do you see how everything is text? Let's look at some of this data now. So when we start looking at this data, we get away from these / shortcuts. If you ever want to see all the / shortcuts, by the way, do \?, you'll see there are a lot of them, including that copy command that we used to copy from the client to the server the data file. There's \d is maybe on the next screen. Let's see. Yeah, here's \d with all of the options you can use. Tables, views, and sequences. There's other stuff, list functions. There's a lot, but I'm kind of starting at the most important stuff, which is the data itself. There's formatting. It's pretty funny. You can, if you ever need a quick hack to build like a data table out of this stuff, try the \h command, capital \h. So our output format is HTML, and now if we select star from our denormalized courses, limit 3, now you've got a quick way to generate based on columnar data, the HTML that will let you quickly like put it in a demo page or something like that. It's pretty cool stuff. So, I will turn that off though, because it's a super annoying way to query normal data. Format is aligned. Now I want to teach you one more of these backslash commands though, and I'll show you why. So let's look at this data. Select star. Star is a way of saying all of the columns. We're going to select star from our table. This select from form, the select from. The format of all select queries is select some set of columns, including running functions over those columns sometimes, from, so here's where the columns go, from something that gives us a table, something that gives us a relation. So this can be, as is above, the literal table, but it can also be a subquery that gets us a table. You can call these common table expressions, I think. Anything that will give you a set of data. So it's a for those of you that like functional programming and like filters and maps and reduces. Reduces are a little trickier in SQL, but this feels very much like that same paradigm. Whatever the data set is, it's got it's like objects that have properties. It's an array of objects. Let me select a subset of the fields from each object from some array of objects. That's the way you think about it in like JavaScript, for instance, or Python. It's a list of dicts. Is it list or array? I don't remember in Python. Anyways, you're selecting some of the fields in each dictionary from that list or array of dictionaries. That's what we're doing with SQL when we select. So we're going to select star, which is like saying, give me all of the fields from denormalized courses. Now there are 17,000 something records in here, so we're going to do a limit 3. But we're going to see something ugly when we do this. Super ugly, right? It's a table view. It's an ASCII art table view that way extends beyond our screen. So there's a fun little trick we can do here, which is to do \x, and we can set x for extended on. So when we have extended data sets, we can do \x on. Extended display is now on, and if we do that same query, we'll have a much nicer way of seeing the data. So here's record 1, key value pairs all the way down. Takes more vertical space, but now we can see what's actually going on in this data set. \x off turns that off. The way to do this, though, and this is like so central to the way you query in pSQL that people often do this in their pSQL RC, their configuration file, is \x auto. So extended display will now be used when there are wide data sets, but if there are narrow ones, then we'll select a different way. So if I select only course and number, and these fields, by the way, are comma separated, select course and number from denormalized courses, limit, say, 20 in this case. Always semicolons after SQL statements. The \/ statements, you'll notice, don't take semicolons, so there's a difference between these two languages. If I select, now you'll see it's a narrow table, so we can use the ASCII art table view, and it's clean. Selecting all of them, it'll automatically switch, and I'll do only 2 rows, so it's not too much. We'll automatically switch to that extended view. Right, so that's like, this is the basic way of exploring the data. We're finding different ways of turning display options on and off, and we're selecting a few records to see what this data feels like in the table. In the same way that you can see it in Excel, now we can see it inside of SQL. Any questions so far? All right, onwards. So you might ask, like, why? I can just hook up my Django code base or my Ruby on Rails in Ruby code base. I can hook up something called an ORM, an object relational mapper, that automatically makes my migrations for me and reads the data in and out of my SQL database. So I benefit from the database while working in Python or Ruby. The question might come like, why would I want to work in raw SQL inside of the database? Isn't it like working in assembly when you have C++ or Python or something like that? The answer is kind of. The beauty of SQL is it is optimized not for general purpose programming, but it's optimized for asking questions. So if a database is like your source of truth in your application, it's the thing that even if your server blows up, a data center goes down where all of your server processes in your Kubernetes cluster are running, that whole thing goes down. The database is a managed single server. Thus, it's although you can run replicas as well, which even if the server itself shuts down, it makes sure it's always persisting this data to the disk. So it is the source of truth. It's where the data is consistent inside of your application. SQL is optimized for asking questions that you don't even know yet of that data in like 1 or 2 lines of code. So while Python might be a nicer way to think about, you know, get this particular property out and then send it in a request response over HTTP to a front end, SQL is a much nicer way, once you get used to the language, of asking questions like, how many users in the last 2 weeks have not logged in who previously were active users? So this is the kind of question that a business will ask when it wants to know, you know, who has dropped off in recent usage. Maybe we can figure out if there's a bug or if we've done something that broke their logins. These kinds of questions are much, much easier to ask in SQL. So this data set that we have, this denormalized core set, we're going to ask some questions of it right now. You've seen a few rows. I'll put them up again. Limit 2. So here's record 1. It's a course called Arabic and Islamic Studies. Here's the course code. Here's the course number. Or this, like the, what is this? It's like Math 101. This is the course number in the sense of, and these names suck, by the way. And then there's the course number, which is the actual enrollment number that works inside the database to make sure you're in the right course. Then there's the class number, which is distinct, and the section number as well, kind of a hierarchy of these things. There's the minimum, maximum hours. There's the time that the course runs. And then there's like information about the instructor and the location. It's everything about each of these courses. Does anybody have any questions they want to ask about every single course section running in KU in fall of 21? If not, don't worry, I have some questions to ask of the data set. And you don't have to write them in SQL, by the way. You can write them in English. Okay, so here's a question I have. What department, because that's really what these codes are. It's a departmental code. What department runs the most course sections in fall 21? What if I can only take classes at 8 a.m.? What are my options? Perfect, cool. Let's roll with that one. I like it, Connor. Thank you for inventing a use case here. Okay, so select star from denormalized courses, limit 2. First thing we want to do is get rid of the limit 2. We know we're selecting from this table. Let's start from here and let's build up a query that gets us that information. So we still, let's say for now, we'll still select all of the columns, but now we need to filter down the rows. If we just run this, we'll get back all 17,000 rows. We have a condition, and the way that we introduce a condition to a query like this is select from denormalized courses where. Now, quick note, a lot of times when you see SQL, you'll see it like this, right? All of the keywords, all of the words that are part of the SQL language are in all caps, and then all of your column names and table names are lowercase. The reason for this is it applies here, but it's purely historical. It's that syntax highlighting was like not even a thought when SQL was written. SQL is of the same age as the language COBOL. And so the whole idea behind this was like the business-friendly language for back then. Can we let business users who have questions like, you know, how many courses are at 8 a.m., can we let them write something that's like English to get the data out of the system? So it reads a little bit like English. Select all or select star from denormalized courses where, and this is the thing we're introducing. So this is a condition. This is a filter. This is, we did Instagram filters last hour, and now we're doing SQL filters, and these are like not as cool, to be honest, but super useful. So select star, select all the columns from the denormalized course rows where, and then start. Notice there's a start column right here. start, and I'm going to say like. Like is kind of a regex-like language or a glob-like language, and it should really be like this since it's a SQL keyword. And then we're going to give that a pattern. So we want something that looks like 8, and then, well, I bet it starts with a 0. We're about to find out though. And then anything after that. Let's try this just for an interactive query to start. Okay, that's looking pretty good. That looks like an 8 o'clock. Now we have wide columns here, so let's scope down our query to only see, say, like course, number, and start, and maybe end as well, because end is of the same kind of data. Let's try that same query. Look, start. This is a fun trick. So end, note, is a name of a field in the database. This is a special case though. End is also a SQL keyword. So when you have a keyword, SQL is very, very flexible about letting you still use it as a name for a column or a name for a table. You just have to do this double quoting here. So that should let us run our query. It's a fun little quirk that you'll run into and hit your head against for hours unless you're looking out for it. And this looks pretty clean. These are all 8 a.m. What I'm worried about though is, do we have any 8 p.m. classes later on? Oh, look at that. There's a PM, but that's probably from 8:30 in the morning. So this is an inexact data format, isn't it, right? What would be ideal here is if instead of text, we transform these into dates. Now we're getting on, it's 4:55. I don't think we're gonna have time to do all of the casting we could, but basically, if we want to cast any of these text types to the rich set of data types that's inside of Postgres, it's a double colon syntax. So say we want to turn number into an int, right? Then we can do the same thing. And now, as you can see, it's right aligned. We've got ints. If we wanted to cast, actually, I'm not sure what's going to happen here. Let's try it. Date, time. No, doesn't exist. Sorry, I'm thinking in JavaScript. Let's try time. Okay, so now we've got time, so that looks pretty clean. But what's going to happen here if we have an 8 p.m. that's implicit, right? It's going to look like 8 or 8:30, and then it's going to end up, there we go, here's an example. So this is really from 8 to 10 p.m. So we're going to need some conditional logic later on. I want to show you one important hack that very few database courses teach, which is incredibly pragmatic inside of Postgres. If you ever want to do like a full text search, right? We can filter on particular columns, no problem. You can do this neat trick where you actually pass the name of the database itself back. So where denormalized courses, and I think it's optional, but we'll cast the entire row as text. This is going to create it's two stringing the whole row. And then we can do something like, and then we'll put a variable placeholder on one side. This is like .star in regex, and then we'll look for PM. It's an imprecise search, but we'll see what it turns up for us. What have we got here? Invalid for type time appointment. So now we know something else dirty about our data, right? Some courses don't have a set time, they're appointment courses. So for now, we can't yet quite cast start to a time. Let's do it this way though. Okay. So we also, where denormalized courses has PM, oops, hang on, and still want our previous filter, which is that our start is like 8:0 colon and then everything else. Cool. So now we've got the candidates for these conditional things where we assume this course doesn't actually take 14 hours. So now we have a way to quickly filter down to those courses that are likely to be PM instead of AM. And what we would do is we would make this a conditional cast. We would add 12 hours, basically, in the case where we heuristically thought this was likely to be a PM. But when it comes down to it, this is data engineering. We don't know for sure this data set, as it comes out of the API, as it comes out of the website, is lossy. So thinking politically, thinking within an organization, how do I get the real data? It's like, oh, maybe we need access to the original database instead of this roundabout way of getting it. But for now, we would make a heuristic decision to set these likely candidates somewhere where the time span between the two times was more than, say, 4 hours. That's a point at which we would choose the 8 o'clocks and the 7 o'clocks to be PM instead of AM. Funny quirk of the data set here. But these are the kinds of questions, yet again, that SQL allows you to quickly drill down on, right? If I'm doing this in Python, I think I probably never even discovered that this is an issue until this data makes it into production and like blows up my course scheduler app. So hopefully you see some of the power of knowing this language that is so close to the data and the schema that it's in. Oh man, I wish we weren't out of time. It's 4:59 already. I hope what you've seen so far helps you to understand, two things. One, that SQL is a powerful, if sometimes like thorny, right? This is a pretty crazy one-liner when you look at it. But it's a very powerful language to query over this data. And second, you've now learned to take real-world data and get it in a form where you can use this language. So you have two steps, right? The third step, which we won't have time for today, unfortunately, is like, how do you take this wide denormalized table, unnormalized table, which has many quirks in it. I'll show you another quirk. Select course number instructor. We're going to select these from denormalized courses, where instructor is like has a semicolon in it. And I'll show you why this matters now. Turns out there are courses where the instructor is many instructors. This is very bad for doing querying, right? If we wanted to count how many instructors are in the data set total, we could do that if this were clean by saying select count of distinct of instructor from denormalized courses. We might say, oh, that's awesome. There are 2,417 instructors. But if we remove that count, what we see very quickly is that this is a false conclusion from the data. It's messy. We see immediately those semicolon data. So we would actually continue to clean this data set if we had time. We would split these. We would create a separate instructor table, which was just the instructors, one instructor name distinct per row, and then we might join information about those instructors, things like their emails, their names, their bio pictures, from another ETL job into this. And before you know it, you're to a place where you've created a whole relational, normalized data set that you can build anything on top of. We can build our course selector, scheduler. We can build, as we were doing here, like a course analytics tool to figure out how many courses fit different interactive querying requirements. We could build an application that does an ETL of every course schedule from every college in the US and makes comparisons of this data because we normalize into the same table structure. Now we have the power to back the projects that we make with real life data. And that's what I really wanted to share with you during this workshop. Nice, RIPU if you have to take classes at 8 a.m. I used to think that too, and now I have work meetings sometimes at like 7 a.m. for some of my gigs because we're across all time zones. So are there any last questions? Any questions about either the content that we covered here or questions that you want to figure out in this data set that we can interactively query together? I wish I could like open it to chat for everybody. Maybe that's not possible though. Actually, is that Connor? Maybe you can tell me. Connor, is it, if you're still here, is it possible to let everybody like be seen on the screen now and ask questions? He may be out of here already. I'm just clicking random stuff. It doesn't seem to be working so far. Oh, share. People can join using share audio and video. Yeah, if anyone has a question and wants to hop on that way, feel free to do that, share audio and video. If not, you can also ask your question in the chat. Meanwhile, I'll start querying a few more things. You can drop, by the way, want to make sure to respect everybody's time. It's 3 minutes after 5. We started at 3 minutes after 4. But what I'm going to do right now is like take some of this data and start to normalize it, start to pull the distinct values out into separate tables. One of the ways we can do that is by creating additional tables. So create table, we're going to create a departments table. Create table departments. And we're going to use an as clause here, which lets us create a table as the result of another query. Create table departments as select distinct. It was what's the name of that course? Yeah, so select distinct course. Normalized courses. What have we done? Select distinct. Oh, right. Do that. There you go. Okay, so we now know we have 275 departments. If we look at that, let's select star departments. We see we only have the course. Now we might want an ID so that we know a course and can change its name, but it still stays to be the same course. So in addition to creating tables, we can alter table. Alter table, what was it, departments? Yep. Let's see, what do we really want to do? We want to add a column. And by the way, I totally Google SQL all the time. It's freaking huge. It's the largest language you'll work with day to day as a dev. So alter table, add column, I think is what it is. But I'm just going to make sure, yes. So alter table, add column. And we're going to add a column which is called ID, and it is of type serial. Let's see if we get it right on the first try. Nice. So now if we select star departments, see that they all have IDs. Now we can use those IDs to join with other tables. This is part of the normalization of our data set. So what we would do if we had more time is pull all of these distinct entities out. In addition, inside of the web side here, underneath this one folder, I've also got data here. Just to show you how dirty this kind of ETL work can get. For the next table, I found a place where these department codes or subject codes have their actual like full text English descriptions. And you can see popping back here that the way we get those out is literally copy and paste from that table. And then open sheets.new in a browser tab, so something like this. We'll do this one, and then I think we'll call it after this. Get those course catalog codes, grab them this way, yoink, almost there. Awesome, all the way down to Wolof and Women's Studies. We copy that. Here's a quick way to get CSV if you ever need it, sheets.new. Seems we're in an HTML table. Google Sheets is very smart about that and lets us paste them in here. It's now downloadable as a CSV file, and then we can load that into the database in the same way that we did previously. But in doing so, we see that there's this weird repetition of the code itself and then parentheses. And this is where in the, where is it? No, over here, the original data cleaning, you'll see that I do a find and replace inside of Google Sheets itself. with a regex to get rid of all the parentheses. We find that the parentheses can be nested inside of this data. So this is the 80% of the work that ends up being cleaning it before you even have it in the SQL database. But what this can get us to is an additional subjects row, which is overlapping with that table. We can join the two together and then have codes and names of codes as well. So lots more we could do, but we are out of time, unfortunately. Any last questions before we finish up the workshop? Cool. I hope you have learned a few things about what it's like to get real-world data sets, what it's like to use SQL to interactively query them, just the beginning of how we might normalize those data sets so that they're useful in an application, and then lots of little P-SQL tricks on the way, things like the D that we learned, the D for a table, just to review, using \x in order to make your display not a mess and to make it auto, like so. Oops. And then hierarchy of things that happens inside of a Postgres database, right? All the way from the cluster to the database, to the schema, to the tables or relations themselves. And that is it. I think we're all wrapped up. Cool. All right. Thanks, everybody. I'll resume the soundtrack I started at the beginning and fade out slowly. Right. Peace. Bye.